and hemisphere, right? And we solved till question number 4 in the worksheet. Question number 4 or 5? 4. Yes, Aditya, can you tell? Which question we have to start? Sorry? 4 or 5. This is a nice thing. We have to start from this problem. A cubical block of 7 centimeters is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Question number 1. And also find the surface area of the solid that has been formed. So students, just recap. Yesterday we solved how a hemisphere has a cylinder top of it, how a hemisphere have a cone top of it. That is what we have done. Now today we have something very similar to that. You have made a hemisphere to sit on the cube. So note that what is the greatest diameter that this hemisphere can have is nothing but the length of the cube, the side of the cube. That is the maximum diameter that it can put. So let's try to imagine, because you can't draw the figure. Okay, but if you can able to draw, that's fine. But you have to imagine this. This cubical box is of side 7 centimeters like this. Now, students, you need to tell what is the greatest diameter the hemisphere can have. This is the question mark, as you are aware of. The maximum diameter that this hemisphere can have will be equal to the length of the cube, correct? The length of the cube. Therefore, the greatest diameter will be equal to the side of a square, which is equal to 7 centimeters. You are done with the first sub question here, correct? This is the only choice you have. There is no other choice left. Next, the second sub question here goes like, find the surface area of the solid. So please see the solid, students. This solid is made up of one cube and one hemisphere. So if I want to find the total surface area, yesterday also we had a discussion. When the word surface area is used, you should find the total surface area. So how you will find the surface area of the solid? You just see, let's find the total surface area of the cube. That is all the 6 sides of this cube plus, or let's do one thing, we will subtract the extra thing. What is that? Base of the hemisphere we will remove, correct? We don't want that area. It should be it will be duplicated, right? Then we will add the lateral surface area or the curved surface area of a hemisphere. That is the outer part. Can you imagine this? Understood?
So
CS and you will not have the base. ಯಾಕೆಂದ್ರೆ TSF ಕ್ಯೂಬಲ್ ಅದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿರ್ತೀವಿ. Correcta? Say something like, you can imagine like this, students. See, I'll just write the cross section. Cross section ಅಂದ್ರೆ ಅರ್ಥ ಆಗತ್ತಲ್ವಾ? A top region. I have a circle. What type of circle is this? Is it a circumscribed circle or cyclic? Circumscribed. Now I want to find the area of this 4 regions that you can see on the outer part.
Area of circle minus
Area of square minus area of circle. Presence of mind is important. Is it correct? Students, note that shaded part, the region is quite difficult to find. Since I have used TSA, I get the entire region. See, that is what I showed. TSA means what? Entire. Now what I do, I remove that circle base. That is the base of the diameter. The base of the hemisphere. Then I add the third surface area of the hemisphere. That is the outer part of the hemisphere. So that gives us the total area of the solid. So now we know that the total surface area of the cube is given by the formula 6L square or 6 side square, whatever you can write. And note that the base of the hemisphere looks like a circle, therefore it is pi r square. And curved surface area of hemisphere is given by 2 pi r square. So let's quickly see whether we know all these terminologies or not. Since we know that the cubical block is of side 7 centimeter, definitely we know the side, that is L is known. So do we know the radius? Definitely yes, because the greatest diameter of that hemisphere is nothing but 7 centimeter, means therefore the radius would be 7 by 2, correct? Essentially, you can write 3.5 or you keep 7 by 2 itself, students. Let's keep this for calculation purpose. So both the R's, everything is done. So what we are left with? We are left with substitutions. That's all, right? So as I mentioned, what two people can do is you can do the simplification separately or you can do all at one stretch. That's up to you guys. So we know the side of the cube. We know the radius of the hemisphere. We know the radius of the circle. That's enough to complete the problem. So now I'll find the TSA of a cube, that is 6L squared, which is 6 into 7 squared. So it's 6 into 49, which gives us 294 centimeter square. Should I make you to understand why 6 into 49 is 294? Everyone are aware of? Multiplication, correct. Okay. Next. Surface area of the solid is equal to TSA of a cube minus base area of a hemisphere plus CSA of a hemisphere. So 294 minus pi r square plus 2 pi r square. See, now this is what I'm telling you, students. Listen. If you just see, I have not calculated the base area and CSA separately. You know why?
Pi r square.
You have 2 pi r square and you're subtracting 1 pi r square. Means, is it only finding 1 pi r square? Yes or no? So instead of doing base area separately and CSA separately, if I mix both together, is it a time management skill? So what you do, it will be pi r square. Therefore, pi means 22 by 7 and we are lucky because r is 7 by 2, correct? So now you can simplify easily. 7 gets cancelled 2 times and 2 11 times. So 77 by 2. 77 by 2 is easy to do, which is 38.5. So add 38.5 to 294 to get the answer 332.5 centimeters square. Hence, the total surface area of the given solid is 332.5 centimeter squared. Then students, ಬರಲಿಲ್ವಾ ಯಾಕೆ ಮಾಡೋಣ ಅಂದ್ರೆ ಆಮೇಲೆ yes can we go for that? I don't know for whom I am asking.
Yeah.
Can we go further?
Yes, sir.
Okay.
Yes, sir.
The next question is, a hemispherical depression is cut from one face of a cubical wooden block such that the diameter L of the hemisphere, please note that students, that is L, not 1. Please see the question. It's the diameter L of the hemisphere is equal to the edge of the cube. So determine the surface area of the solid. So first what we will do, we will imagine a cubical wooden block. Cubical wooden block means, you know, It's a cuboid shape. Now you have to cut one face of this. You have to cut one face. So if you cut that face, it forms a hemisphere. So just to have this thought process, what you do, you just imagine a scoop of an ice cream. When you know how they pick the scoop, initially the ice cream will be in the form of a cuboid, right? So you just neatly scoop. You're understanding? So that becomes the that forms one scooping ತಗೊಂಡ್ರೆ ಏನಾಗ್ತಾ ಇದೆ ಹೆಮಿಸ್ಫಿಯರ್ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಬಟ್ ಇಟ್ ಈಸ್ ಇನ್ಸೈಡ್ ಕರೆಕ್ಟಾ ಇಟ್ ಈಸ್ ಇನ್ಸೈಡ್ ಕಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಒಳಗಡೆ ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಯು ಹ್ಯಾವ್ ಟು ಇಮ್ಯಾಜಿನ್ ಇನ್ ದ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಇಟ್ ವಾಸ್ ಅಬೌವ್ ಇಟ್ ಕರೆಕ್ಟ್ ನೌ ಇಟ್ ಈಸ್ inside. But note that the diameter of the hemisphere is same as the edge of the cube. Yesterday also we had a discussion, if you remember. Edge means not the corner. Edge means it is a line, correct? So they are telling that the diameter of the hemisphere is equal to the edge of the cube. Cube means all sides are equal, correct? That is L. Again, I repeat, students, it's not 1. Okay, it's not 1. Are equal. So now what you have to do, you have to find There is some technical issue. No. Okay. Yeah, students, sorry. There was quite a technical issue. Where I was? ಇನ್ನೇನು ಟೆಕ್ನಿಕಲ್ ಇಶ್ಯೂ ಇಲ್ಲ, ಇರೋ ಒಂದೇ ಆನ್ಲೈನ್ ಅಲ್ಲೇ ಹೋಗಿತ್ತು. ಕ್ವಶನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ದಾಗಿತ್ತ ಇಂಟರ್ನೆಟ್?
No, sir. You started explaining that
Okay.
edge of the cube and then it went.
That's fine. I'll start. I hope everyone are there in the class. Okay, so let me start from the beginning. So there is a cubical block. There is a cubical block, and a hemisphere is cut from one face of the cube such that, let us see that later. So let us take one hemispherical depression from the top face. That means depression means you have to cut. Depression means seeing down, right? Trigonometry lo nodidvi. The concept of cutting this hemisphere from the cube is like the diameter of this hemisphere is equal to the edge of the cube. So what is the meaning of edge? It is a line, correct? Corners means the vertex. Edges means lines. So the diameter of the hemisphere is equal to the edge of the cube. This is what they have given. Therefore, edge of the cube is equal to the diameter of the hemisphere, which is equal to L. Students, please note that here it is not 1, it is the letter L. It is the letter L. Now, we can easily calculate the radius of the hemisphere because we know the diameter of the hemisphere, which is L, which is L by 2, correct? Now, we have to find the surface area of the remaining solid. That is, after the portion of the hemisphere which is cut from this cube, we got a shape. That shaped surface area we have to calculate. So to do that, what I'll do, I'll calculate the total surface area of the cube. That is, I consider the complete cube and subtract first the circle part of the top. That is the hemispherical top minus hemispherical top plus I have to find the curved surface area of the hemisphere. So it is TSA of a hemisphere. Did you understand this, students? If you can able to understand, the previous problem and this problem is of same idea. This is what I was explaining. Just try to connect the previous problem and this problem. In the previous problem, you have kept a hemisphere on the top of the cube. The total surface area of this solid is same. In this problem, you are finding the total surface area when you cut the hemisphere inside the cube. So the two total surface area of those two figures will be same because there is a common condition in both the things is that the diameter of the sphere, hemisphere is equal to the edge of the cube. So what is the difference is the volume. In this problem, the volume will be lesser. In the previous problem, the volume will be greater. Is that clear? Is this thought process clear? ಇದನ್ನೆಲ್ಲ ನೀವು ರಿಮಾರ್ಕ್ ತರ ಬರ್ಕೋತಾ ಇರಿ ಸ್ಟೂಡೆಂಟ್ಸ್. Okay, you start writing it as a remark. Now, let's substitute the formula. What is the surface area of the cube? We have the formula. What is the surface area of the cube? It is 6L squared. See, when I use the word surface area, you should not use only the vertical surface area or the lateral surface area. You have to use the total surface area. All minus area of the hemispherical top, which is circle, plus the curved surface area of the hemisphere, which is 2 pi r squared. Now we know that the simplification of minus pi r squared plus 2 pi r squared is 1 pi r squared. So it will be 6L squared plus pi r squared. And we know what is R in this problem. What is R in this problem? It is L by 2 whole square. Now simplify. What is L by 2 whole square? It is L squared by 4. L squared by 4. Now take the LCM. If you take the LCM, what happens? 24L squared plus pi L squared by 4. So you can rewrite this as 1 by 4 into, you can take L squared common and 24 plus pi square units. That's all. Because L is unknown, so you cannot simplify further. Therefore, the surface area of the remaining solid is 1 by 4 L squared into 24 pi. Any doubt, students?
No, sir.
I want to write one remark or note at this stage. Shall I proceed?
Yes, sir.
And I want you people to help me. What is the question number here?
7.
7. So just let's compare question number 6 and question number 7. In question number 6, the cube was on the top of the, the hemisphere was on the top of the cube, whereas in the question number 7, the hemisphere was inside the cube. What is the answer we got in question number 6? 332.5 centimeters square, correct? Yes, Manito, Aditya, can you tell? Please, correct answer work over. Correct answer in him verify. Aditya, is this the
Sir,
answer that we got?
This is the answer.
Okay. Now, what is the question number 7 answer? 1 by 4 into 1 by 4 into L squared into 24 plus 5. So, students, in the previous question, that is question number 6, what was the diameter? This is the surface area of the solid, correct? What was the diameter? 7. Now here it was L. And note that both the concepts are same. Means if I substitute L is equal to 7, should I get 332.5? Definitely you should get. Okay. So what you do later has a verification part. You put L as 7. Okay. And try solving. I'm just doing it in the calculator quickly. I got exactly 332.5. Perfect. Okay, try that. Then what is the
Sir?
difference? Yes.
Sorry, I wasn't there for the 6th question, but for what is the greatest diameter the hemisphere can have? It's 7 centimeter only, right?
Exactly. See, you just imagine a cube, you are placing a hemisphere to the top of it. What is the maximum diameter it can have? Is it will be equal to the edge? Yes or no?
Yes. Yes, sir.
Now, students, in question number 6, you know the nature of the figure. See, I cannot write 3D. You have to imagine. What will be the volume occupied in question number 6 figure? It will be the volume of the cube plus the volume of the hemisphere. Whereas in question number 7, the volume of this solid will be volume of the cube minus the volume of the hemisphere. Is that clear? See, ನೀವು ಈ ತರ ಡಿಫರೆನ್ಸ್ ಅರ್ಥ ಮಾಡ್ಕೋತಾ ಇದ್ರೆ ನಿಮ್ಗೆ ಸಬ್ಜೆಕ್ಟ್ ಅರ್ಥ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇದೆಲ್ಲ ಬರ್ಕೊಳ್ಳಿ. ಏರಿಯಾ ಸೇಮ್ ಇದೆಯಲ್ಲ, ಬಟ್ ನೋಡಕ್ ಎರಡು ಬೇರೆ ಬೇರೆ ತರ ಇದೆ, ಕರೆಕ್ಟಾ? Look, it looks different. That means, students, the solid that you see may look different, but areas may be same. ಬಟ್ ಎಲ್ಲಿ ಡಿಫರ್ ಆಗ್ಬೋದು? ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ಡಿಫರ್ ಆಗ್ಬೋದು. That's the example of these two questions. Understood the note or remark? Students, I'll tell you, when I try to explain this problem, ಎಲ್ಲ ತಲೆಗೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ, ಮನೆಗೆ ಹೋದ್ರೆ ಎಲ್ಲ ಮರ್ತೋಗ್ತಾ ಇರುತ್ತೆ. So you have to write everything point to point. ನಾನು ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದಾಗ ಆ ತರದ್ದು ನೀವು ತಲೆಗೆ ಹೋಗಿಸ್ಕೋಬೇಕು. I hope everyone are writing.
Yes, sir.
Aditya, no reply.
I'm writing, sir.
See, when I ask you the question to you guys, you should respond, okay? Even you also here. Whatever. Okay. Can I erase? Okay. The next question. There is a medicine capsule. You might have seen this, which is in the shape of a cylinder with two hemispheres stuck to each other on its ends. So you can imagine this. Correct? You can imagine this. Because there is a cylinder and two hemispheres are stuck to each other on its ends. The length of the entire capsule is 14 millimeter. Don't read it as 14 meters. Astu the capsule yagu iralla. Even 14 centimeter capsule iralla. Forget about meters. 14 centimeters andre nim scale astu. It's a 14 millimeter. Okay, jokes apart. The diameter of this capsule is 5 millimeter. In one sense, students, can we take it as a width of the capsule? Width of the capsule is 5 millimeter. So find its surface area. So as soon as this figure comes to our mind, you are trying to adjoin three things. The total surface area of this capsule is the curved surface area of the cylinder, curved surface area of the cylinder plus
2 into CSF.
very good, 2 into CSF, one hemisphere, which is same as area of one sphere also. But don't use the word sphere because they are using the word hemisphere. But actually, students, since the two hemispheres are congruent, please understand my language. I am recapping the word congruent because it has the same shape and same size. These two have the same shape and same size. So it constitutes one sphere actually. Simply for simplification purpose, I am calling the curved surface area of cylinder as capital letter S1. And curved surface area of the hemisphere, we are calling it as by the letter capital letter S2. It's for just notation purpose. Yes, Arya, what is the curved surface area of the cylinder?
Pi r square h.
It's 2 pi r h. See, I won't expect that you people will tell the formula by remembering it. At least for the class, you have a cheat sheet. And see, when you try to remember what happens, we may forget. We all are human beings. We have to accept that fact. But at the cheat sheet, it can't class and you ready ಆಗ್ತಿದ್ರೆ, knowingly or unknowingly, what you will recall, you will see and you will recall. One or the other day, memorization now. What is the curved surface area of the hemisphere, Chirashwi? It is 2 pi r square. Okay. So now let us see the parameters that is required. We want radius and height. Since the diameter is given, which is 5 millimeter, we can divide it by 2 to get the radius, which is 5 by 2 millimeters, correct? Which is 2.5 millimeters. Or even you can take it as 5 by 2. That's not a matter. So radius is done. Now we have to find the height of the cylinder. So the length of this cylinder or the height of the cylinder is equal to 14 minus 2.5 minus 2.5. Will you agree? Yesterday also we solved the similar type of problem. If you have attended my yesterday's class. The total height of the toy was given. We subtracted the sphere or hemisphere radius and we got that height. So on similar lines, it is 9 millimeter. So even our problem is solved of finding height. So now I'll calculate the curved surface area of the cylinder and hemisphere separately, which is 2 pi RH. And I write it as 2 into pi into 2.5 into 9. Which comes out to be 45 pi millimeter square. Students, intentionally I have not solved pi. Okay, I know that even in curved surface area I'll get pi. So I club those two. So the curved surface area of the two hemispheres is 2 into 2 pi r squared, which is 2 into 2 pi r into 2.5 whole square. After simplification, you will get it as 25 pi millimeter square. I guess for everyone, there is no need of me explaining how 2 into 2 into pi into 2.5 whole square is 25 pi. Should I explain? See, should I explain means it's a question I am asking.
No, sir.
No, sir.
Okay. Now it's easy to add 25 pi plus 45 pi. What is 25 plus 45 pi? It is 70 pi. Is it 70 pi? Now our life is so easy, students. Why our life is easy?
22 by 7. 7 10.
So the total surface area of the capsule is S1 plus S2, which I am calling it as 45 pi plus 25 pi, and hence it is 70 pi. So 70 into 22 by 7 is 220 millimeter square. Therefore, the surface area of the capsule is 220 millimeter square. Now I will build one story for the same question, students. A medicine has to be put inside this capsule. What is the amount of medicine I can put inside?
Volume or
Can you find the volume with the same data? Definitely yes. See, so for all the questions that we are trying to solve now, you can convert all those problems to volume. You can convert all the problems to volume. Is that clear? Okay. See, other question ಹಾಕೊಳ್ಳಿ. ನೀವೇ question ಕೇಳ್ಕೊಳ್ಳಿ ಅಲ್ಲಿ. Can I find the volume of this medicine capsule? Question mark. ನೀವೇ ಬರ್ಕೊಳ್ಳಿ last ಅಲ್ಲಿ. Can I find? Because if you write, you are only raising the question. Can I find the volume of the medicine capsule? ಯಾಕೆ ಎಕ್ಸ್ಟ್ರಾ ಕ್ವಶನ್ ಬೇಕು? ಇಲ್ಲೇ ಇದೆಯಲ್ಲ ನಮ್ಮ ಹತ್ರನೇ. Okay, next question ಹೋಗೋಣ. Ready na? Okay. There is a tent. Let us see. There is a tent in the shape of a cylinder surmounted by a conical top. You can imagine that, students. There is a cylinder, there is a conical top above it. If the height of the cylindrical part, so please understand they are talking only about this part, is 2.1 meter, and the diameter of the cylindrical part is 4 meters. And the slant height of the top, yesterday we saw the difference between the height and slant height of the cone. Hopefully you remember. It's 2.8 meters. Find the area of the canvas used for making this tent. Also find the cost of the canvas of the tent at the rate of 500 rupees per meter square.
Yes.
So note that the base of the tent will not be covered. So you have to neglect the base. So definitely in our mind, the first thing should strike in our mind is to find the area of the canvas, that is the area of the tent, will be equal to the curved surface area of the cone, only the top region, correct? plus the curved surface area of the cylinder that is at the bottom. Note that students, here for pictorial representation, I have opened at the middle. Even don't worry to open there. So a natural question, what is the curved surface area of the cone? It's pi r L. Lucky, we know the slant height. Suppose height of the cone ಕೊಟ್ಟಿದ್ರೆ Pythagoras theorem use ಮಾಡಿಕೊಂಡು ನೆನ್ನೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಮಾಡಿದ್ವಿ ಅದು. Okay, yesterday we had done. So just revisit that, else we will discuss. Next, what is the CSA of a cylinder? It is 2 pi RH. But don't get confused with H of the cone and H of the cylinder here, students. The H of the cone is different from H of the cylinder here. Okay. So do we know all the data? Yes, slant height is known. Height and is known. The radius is not known directly, but we can find because diameter is 4 meters means the radius is 2. And one more thing I want to tell you guys, make sure that all the parameters involved will be of same units. Ella meters alla irbeku ಅಥವಾ ella centimeter adu ide ella problem allu tondre ಇಲ್ಲ. So now we are in a position to find the total surface area of the tent. Then we will find the cost because we know that the area into the cost gives you the total cost for making that canvas. Shall we proceed? I'm not doing any simplification part. The curved surface area of the cone, that is S1, is equal to pi RL, which is pi into R is 2 and slant height is 2.8, and it is easy to multiply 2.8 with 2, which is 5.65 meters squared. And curved surface area of the cylinder is given by 2 pi RH, which is 2 into pi into R is 2 and H is 2.1. 2.1. So 2.1 into 4 direct, it becomes 8.4 meters square. Now students, you see, again we are lucky. If we add 5.6 and 8.4, what we'll get? 0.6.4 contributes 1. So 9 plus 5 becomes 14. So is it 14 pi? So if it is a 14 pi, again we are lucky. Why? 22.7. See, each step you admire the problem. Wow, easy. ನೀವು ಇಲ್ಲೇ 22/7 ಹಾಕೊಂಡಿದ್ರೆ ಅಯ್ಯೋ ಮತ್ತೆ ಕ್ಯಾನ್ಸಲ್, ಬಟ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬಹುದಿತ್ತು. ಯಾಕೆ ಅಲ್ಲಿ 22.8 ನ 28/10 ಬರ್ಕೋಬಹುದಿತ್ತಲ್ಲ, 21 ಆಗ್ತಿತ್ತು. ಬಟ್ ಮಲ್ಟಿಪಲ್ ಟೈಮ್ಸ್ ಅದನ್ನೇ ಮಾಡೋ ಬದಲು ಫೈನಲ್ ಆಗಿ ಮಾಡ್ಕೊಳ್ಳೋದು ಉತ್ತಮ. ಸೊ ಕ್ಯಾನ್ ಐ ಚೇಂಜ್ ದ ಸ್ಲೈಡ್? I hope
Yes.
none of you requires me to explain how you got 55.6 pi or 8.4 pi. So just add that S1 plus S2, which is 5.6 plus 8.4 gives you 14 pi. So 14 into 22/7 gives you 44 meters square is the total area required. Therefore, the total cost of the canvas is equal to
44 meters square times
44 square into rate, that is 500. They are telling for 1 meter square it is 500. So for 44 you multiply, the total cost of the canvas is rupees 22,000. Looks small, but it's a huge tent. 22,000. Costly problem. That's right. So students, trying to understand, we are solving a problem of combination of solids. Hemisphere, you put a cone top of it. Hemisphere, you put a cylinder top of it. Tube, put a hemisphere on top of it. Cylinder, put a cone to top of it. So you can draw multiple things like this. Is that clear? So can I go to the next question?
Yes, sir.
Yes, sir.
Okay. So there is a solid cylinder whose height is 2.5 centimeter and diameter is 1.4 centimeter. So solid means what? Everything is filled. Okay, the height of this is 2.4 centimeter and the diameter is 1.4 centimeter. A conical cavity of the same height and same diameter is hollowed out. Conical cavity of the same height is hollowed out means it is removed outside. Okay, and the height of that cone is 2.4 and the diameter of that cone is 1.4. See, this is what they have done. But before that, they have given that the diameter is 1.4. Let us list it out. Now you have to dig a cone. You have to dig a cone like this. So what is the property of this cone? The property of this cone depends on the property of the cylinder, because it is same as the height and same as the diameter. So what is the property of this cone? The radius will be same as the radius of the cylinder. The height will be also be same as that. But here we have to be very careful because we want slant height. They are given height. So you have to find the total surface area. Additionally, they have done something. You have to round off to the nearest centimeter square. And rounding off concept maadi anta helidare. That is why we will do. So as soon as I remember this figure, the first thing that should come to our mind is we have solved a very similar problem of finding the total surface area when you have dig a hemisphere inside a cube. Or remember one more thing, a note anta barside, if a cylinder is placed and to the top of it if you place a cone, the same ಏನು change ಆಗಲ್ಲ. So how you will find the TSA of this solid? It is the area of the base plus curved surface area of the cylinder. Correct? Plus CSA of a cone. Will you agree? This is another way of attacking.
Sir, why can't we just do total surface area of cylinder plus a curved surface area of cone?
If you do the total surface area of the cylinder, the top is also there. So you have to subtract that.
But that's why we're doing curved surface area of cone, right?
No, this is inside. See, yesterday also I said you were there. If you join two cubes, there will be one duplicate area for the cuboid. And then subtract madabekane. So you just imagine a cone. Sorry. You just imagine a cone. To the top of it, you are placing one cone anta artha madko. So if you find TSA of the cone, cylinder, and curved surface area of the cone, this area is also considered, right? Which I don't want. So you have to subtract this area, which we have already done today. That is why I took a different route in this problem. Ade methodology manad beda anta I took a different route. Is that clear, Arya?
Sir, in that problem, you will have to subtract.
The very first column, maybe you were late for the class. That was the problem.
Yeah, but here isn't it the saying it's same height and same diameter? So it will be.
See, if it is same diameter and same height, that's fine to write the data. But concept artha madkolodadre change agidre nanu a particular ಒಂದು ಬರ್ಕೋತಿದ್ದೆ ಅಷ್ಟೇ.
Okay.
ಲಾಜಿಕ್ ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ?
Yes, sir.
ಆಕ್ಚುಲಿ ಅದೊಂದು ಫಿಗರ್ ಇತ್ತು, ಯಾವುದು ಕ್ಯೂಬ್ ಮೇಲೆ ಒಂದು ಹೆಮಿಸ್ಫಿಯರ್ ಇಟ್ರೆ ಈ ಎಕ್ಸ್ಟ್ರಾ ಇದೆಯಲ್ಲ ಆಚೆ, ಇದು ಬೇಕು, ನಾವು ಒಳಗಡೆ ಇರೋದು ಬೇಡ. ಅವಾಗ್ಲೂ ಹಂಗೆ ಮಾಡಿದ್ವಿ ನಾವು. ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
So I mean to tell here what you can do instead of using this, you could have used the total surface area of cylinder minus area of circle plus curved surface area of cone. Idunu use ಮಾಡಬಹುದಿತ್ತು. Since this already I had explained in one of the problem, I thought of using add one circle, consider the curved surface area, and put the CSF.
Yes.
Is it clear?
Yes.
Okay. Everyone, I guess it's clear. So area of the base, it looks like a circle, so it's pi r square. So the curved surface area of the cylinder is 2 pi r h, and curved surface area of the cone is pi r l. So one thing that's the difference that you should notice. The height of the cylinder in this problem is 2.4 centimeter, so h is known, and the radius you can compute by dividing the diameter, that is 1.4 by 2, which is 0.7 centimeter, or even you can write it as 7 by 10. That's not an issue. So radius is known, but L is a question mark. What is the relation between the height, slant height, and radius of the cone, Aditya?
So L squared is equal to root of R squared plus H squared.
L square Allah. L is equal to, you have already said square root. L is equal to square root of R square plus H square. How you got this? Jeevanika, can you answer? How you got L square is equal to R square plus H square? Yes, Chirasri, how you got L square is equal to R square plus H square? It's because of Pythagoras theorem.
2 butter.
Not two Pythagoras theorem, one Pythagoras theorem. Are there two Pythagoras?
Okay, ಒಂದೇ ಪ್ರಯತ್ನ ತಗೊಂಡ್ರು ಅದಕ್ಕೆ
ಅಷ್ಟೇ.
hypotenuse find out.
Correct? So, square root of R in this question is 0.7 square plus H is 2.4 whole square. So students, don't get confused. See here. What you can do, you guys can write it as 7 squared by 10 squared plus 24 squared by 10 square. You can write like this and simplify. Or it's okay, sir, I can play with decimals, means it's up to you. 0.49 plus 5.76, which turns out to be 6.25. Of course, 6.25 means it is square root of 625 by 100. Oh, sorry, here square root symbol I have missed. It's square root of 625 by 100, which is 25 by 10. Therefore, the slant height L is equal to 2.5 centimeter. So slant height siktu. So once the slant height is known, now can we find the rest of the things easily? Yes or no? So what is the relation between radius, height, and the slant height? Slant height square is equal to radius square plus height square. Can we go further? Hence, the area of the base of the cylinder, which is pi r square, can be written as pi into 0.7 square, which we have already done. It is 0.49 pi square. Curved surface area of the cylinder, which I'm calling it as S1, as 2 pi r h, which is 2 into pi into r is 0.7 and h is 2.4. You do the simplification of 2 into 0.7, which is easy, which becomes 0.14 into 2.4 pi. Now you multiply that, you will get 3.36 pi centimeter square. Similarly, the curved surface area of the cone can be calculated by using the formula pi RL. Therefore, pi into 0.7 into 2.5, which comes out to be 1.75 pi centimeter square. Students, I'm not worried about the calculation part of the problem. I'm leaving that for you people to do. And I'm just explaining you the concept of how to play with numbers using the formulas. Is that clear? At any instance, if you're finding difficulty in solving the numericals, please do ask. I'll teach. You just note the answer. And after the class, have some rest and start working out. Definitely you will get the answer. Now, the total surface area of the remaining solid gives you S1 plus S2 plus area of the base, which we have computed. All those three and add, you will get 5.6. We are lucky again. So it is 117.6 centimeter square is the total surface area of the solid. And if you can see, the next question is also of same idea. Instead of putting a cone, they have put two hemispheres. I'll just give you 1 minute of time. After completing this question, read the next question.
Sir, when we're solving such sums where we have a lot of figures to add up, can we take out pi common?
Yeah, that's what I'm telling you. You can take pi common, but here no need to take pi common because it is something like 0.49x plus 3.36x plus 1.75x.
Yes.
But suppose if you have another term, you can take pi. See, that's the reason why in the previous case, we have not evaluated the value of pi. If pi ಏನ್ ಮಾಡ್ತಾ ಇದೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಾ ಇದೆ 3 ಸಲ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋ ಬದಲು ಒಂದೇ ಸಲ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಇಲ್ಲಿ ಇಲ್ಲೂ ಅಷ್ಟೇ ಸ್ಟೂಡೆಂಟ್ಸ್ there is no need to cancel 7 and 0.8 like this. See, I'm telling you this is one of the way, that's all, but this is not the only way. 5.6 can be written as 56 by 10, right? And it's 22 by 7. Now I guess you can still easily simplify 7. How many are 56? 7 times 1, 7 times 8. Now what is 22 times 8? 176 by 10. What is 176 by 10? Which is 17.6 natural. Is that clear?
Yes, sir.
So again, you can frame some questions like if the volume is asked, the volume of the cylinder minus the volume of the cone. But if you place this cone on the top of the cylinder, the volume of the cylinder plus volume of the cone. But if they had asked volume with the same data, then I would have not calculated slant height, correct? Because for the volume of the cone, slant height is not required. What is the volume of the cone? 1 by 3
R square H.
pi r squared h. So you don't need the slant height. Andre ಯಾವ ಟೈಮಲ್ಲಿ ಸ್ಲಾಂಟ್ ಹೈಟ್ ಬೇಕು, ಯಾವ ಟೈಮಲ್ಲಿ ಸ್ಲಾಂಟ್ ಹೈಟ್ ಬೇಡ ಅನ್ನೋ ಕಾನ್ಫಿಡೆನ್ಸ್ ನಮಗೆ ಇರಬೇಕು, ಅಂದ್ರೆ ಗೊತ್ತಿರಬೇಕು ನಮಗೆ. Okay, now the very next question is of similar type, students. Okay, there is a wooden article which is made by scooping out a hemisphere from the end of a solid cylinder. There is a solid cylinder and they are scooping one hemisphere on one end and another hemisphere on another end. Can you see? Exactly. Very good. Your friend Chirasvi here is guessing. In one sense, it is an opposite of the capsule problem. Problem ಮುಗದೆ ಹೋಯ್ತು ಅಷ್ಟು ಗೊತ್ತಾದ್ರೆ. ಆ ಪ್ರಾಬ್ಲಮ್ಗೂ ಈ ಪ್ರಾಬ್ಲಮ್ಗೂ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಸೇಮ್ ಇರೋದು, ಕರೆಕ್ಟಾ? ಎಲ್ಲ ರೇಡಿಯಸ್ ಸೇಮ್, ಎಲ್ಲೂ ಚೇಂಜ್ ಮಾಡ್ತಿಲ್ಲ ನಾವು. ರೇಡಿಯಸ್ ಚೇಂಜ್ ಮಾಡ್ತಿರೋ ಪ್ರಾಬ್ಲಮ್ ಇದ್ರ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಇದೆ. ಚೇಂಜ್ ಮಾಡೋದನ್ನ ಎಕ್ಸ್ಟ್ರಾ ಪ್ರಾಬ್ಲಮ್ ಹಾಕೊಳ್ಳೋಣ, ಡೋಂಟ್ ವರಿ. So the height of the cylinder is 10 centimeter and the radius of his base is 3.5 centimeter, which is same as the radius of the hemisphere too. So you have to find the total surface area of this article. Means the first thing that should come to our mind is the curved surface area of the cylinder plus the two curved surface area of the hemisphere. Is it correct? Students, don't subtract. Don't subtract. Why you should not subtract? You're not finding volume. ಆಚೆ ಏರಿಯಾನು ಇರುತ್ತೆ, ಒಳಗಡೆ ಏರಿಯಾನು ಇರತ್ತಲ್ಲ, ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ ನಿಮ್ಗೆ ಏರಿಯಾ. Correct? I guess
Sir,
with
we
these,
can't take the two hemispheres as one sphere.
yeah, that's what you can do, but don't do
Okay.
because they have already used the word hemisphere. Area wise, mathematically, what you are telling is 100% right area, but geometrically, you are wrong. Correct?
Yes, sir.
So for that reason.
ಸರ್ ಅದು CSF ಸಿಲಿಂಡರ್ ಮತ್ತೆ 2 ಸ್ಕೂಪ್ಸ್ ಇದೆ, ದಟ್ ಇಸ್ ದಿಸ್ ಹೆಮಿಸ್ಫಿಯರ್. ಅದನ್ನ ಅಲ್ಲಿವರೆಲ್ಲ ತೆಗ್ದಿದಾರಲ್ವಾ, ಅಂದ್ರೆ ಓಕೆ TSA ತಗೊಂಡು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೋಬಹುದು.
TSA ಯಾಕೆ? ನಾನು ಟೋಟಲ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಆಫ್ ಸಿಲಿಂಡರ್ ತಗೊಂಡಿಲ್ವಲ್ಲ. TSA ತಗೊಂಡಿದ್ರೆ ಅಲ್ಲೂ ನಾನು TSA ತಗೋಬೇಕಿತ್ತು, ಮತ್ತೆ ಬೇಕಾಗಿಲ್ಲ. ಟೋಟಲ್ ತಗೊಂಡಿಲ್ಲ, ಔಟರ್ ಮಾತ್ರ ತಗೊಂಡಿಲ್ಲ. Suppose if possible, can you bring some model of the paper like this? ಯೋಚನೆ ಮಾಡಿ. ಮಾಡಲಿಂಗ್ ಅಲ್ಲಿ ಈ ಯಾವ್ದು ಅಂದ್ರೆ ಈ ಸ್ಯಾಂಡ್ ಹಾಕ್ಬಿಟ್ಟು ಟೈಮ್ ನೋಡೋದಿರೋದು ಗೊತ್ತಾ? ಹಿಂಗಿಡ್ತಾರೆ, ಆ ಶೇಪ್ ನೋಡಿ ಹಿಂಗೆ ಇರುತ್ತೆ. ಅವಾಗ ಗೊತ್ತಾಗತ್ತೆ ಆ ಒಳಗಡೆ ಇರೋದು ಕಾಣ್ತಾ ಇರತ್ತೆ, ಆಚೆ ಇರೋದು ಕಾಣ್ತಾ ಇರತ್ತೆ. ಅಂದ್ರೆ ಸರ್ಫೇಸ್ ಏರಿಯಾನ ಆಡ್ ಮಾಡ್ಬೇಕು. ಸೊ ಐ ಲೀವ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್ ಹ್ಯಾಸ್ ಅ ಹೋಮ್ವರ್ಕ್ ಫಾರ್ ಯು because all the things are known, right?
Yes, sir.
Yeah. Okay. So with this, I'll stop the class and I'll continue with the things in the next class. And the question that Arya you had asked,
Yes, sir.
that circle problem. Actually, ನೀನ್ ಲಾಸ್ಟ್ ಟೈಮ್ ಕೇಳಿದಾಗ್ಲೂ ಅದು ಯೋಚನೆ ಮಾಡಿರ್ಲಿಲ್ಲ. ಈಗ ಮೊನ್ನೆ ನೀನ್ ಕೇಳಿದ್ಯಲ್ಲ, ಓಕೆ, ಐ ಜಸ್ಟ್ ಐ ರೈಟ್ ದ ಫಿಗರ್. Was your friend's query. If you are interested, you see this problem. A minute. Can you hit send? Yeah. In the figure, you have a circle. I'll do one thing. Let me stop this screen. I'll share one more screen. 1 minute, so that I can write your problem. One minute, students. Yeah, others can exit if you want, else you can stay back. That's up to you. Yeah. So it was such a nice, simple, interesting question. ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಯ್ತು. ಸೊ ಬಟ್ ಯಾಕೆ ಹೆಲ್ಪ್ ಆಯ್ತು ಅಂತಾನು ನಾನು ಹೇಳ್ತೀನಿ. ನನಗೆ ಆನ್ಸರ್ ಮಾಡಕ್ ಹೆಂಗ್ ಗೊತ್ತಾಯ್ತು ಅಂತಾನು ಐ ಟೆಲ್ ದ ಟ್ರಿಕ್. This was the problem. There is a circle and they have joined the radius like this. OA, OB andro, and they have joined like this. And they are calling it as this angle as A, this angle as B, I mean the side as B, and this is C. And you are asked to find angle AOB. Okay. So idu one line in kottidare, correct?
Yes, sir.
So this was O. This is O. So what is that they have given is they have given that this angle is 25 degree. That is angle CAO is 25 degree anta kottidare. And they have also given this angle, and this angle is 35 degree. That is CBO is 35 degree anta kottidare. So using this you have to find this angle AOB. This was the question mark, right?
Yes, sir.
Actually ಇಲ್ಲಿ ಕ್ವಶನ್ ಕಂಪ್ಲೀಟ್ ಇಲ್ಲ. AOB ಅಂದಾಗ ಅಲ್ಲಿ ಮಾರ್ಕ್ ಮಾಡಬೇಕು. ಯಾಕಂದ್ರೆ ಇವನ್ ದ ಅದರ್ ಆಂಗಲ್ ಇಸ್ ಆಲ್ಸೋ ರಿಫ್ಲೆಕ್ಸ್ ಆಂಗಲ್ AOB, ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದಲ್ಲ.
Yes, sir.
But note that this angle is 25. Why? Because it is an isosceles triangle, correct?
Yes, sir.
Similarly, this angle is 35. So therefore, what is this angle?
Double.
It's 60 degree, correct? 60
yes.
degree, obviously this will be 120 degree. Yes, because the
90.
angle subtended by an
90.
arc at the center is double the angle subtended by it on the remaining part of the circle. Last week, 9th standard students pata madidde.
Yes,
So,
sir.
fix agoytu problem. Clear?
Yes, sir. Thank you, sir.
Okay. So we'll meet you in the next week, and tomorrow you don't have any test nor class. So utilize this Sunday for
Yes, sir.
taking a short break as well as to study. Okay. Thank you.